Hello, statistics student. This video is for chapter 4.3, Binomial Distribution. Part 2. Part 1, we describe what is a binomial distribution and give some example of what can be modeled by binomial distribution so we can calculate probability of it. Now we are actually getting into how to calculate them. So other than using a formula to calculate, which is something that we never fully explore in this course, if you're interested, I'm sure you can find out how people calculate this. It's just that in this course we never go into permutation and combination and factorial, so it's a little difficult to use that to describe it. But we actually do not use it. So because there's so many binomial calculator out there. So there's two that I pick. One is this. It is pretty straightforward to use, but it's a little abstract because there's no graphical display. The other one is from online Statbook Binomial Calculator. This one is a little nicer because it has pictures of the histogram, so you actually know what x you are talking about. But the only drawback is p is only allowed to 2 decimal places. So if your p is 0.001 or 0.123, so you cannot use the online Statbook Binomial Calculator. But so if you are going with p equal to 2 places, then this is actually a little better. But our main one is this, so it is good enough to find probability of x. So statistics can allow us to calculate probability of x equal to a number, probability of x equal to a number or fewer, probability of x or greater. Okay, so I'm going to show you how to access it. So what you do is you go to statistics online, and then when you open it, you should have this, and then you look at probability distribution. You click on it, and you will see normal distribution. We want binomial distribution, and then they will ask you the number of trial n and the probability of success in one trial. So by default it's 10-1, but you can change it. So for example, I'm tossing a 6 coin, and I want to know what it is that I have 2 heads out of the 6 tosses. So no, you would want to know what is this two heads, but my probability of having a head is 0.5, right? 0.5, and then you evaluate. P of x will be here. P of x is 2, so that means probability of x, I have exactly 2 heads out of 6 is 23%. If I have 2 or fewer, that means 2 heads, 1 head, as well as 0 head, that is this percentage. And then I have 2 head, 3, 4, 5, 6 head, all of them add together, that is 0.89. So in a nutshell, you can think of it like this. The binomial calculator from statistics actually give you a table. So if I switch back to the table, switch to a blank page. So they don't give you all the p of x. When you say x equal to 2, they will give you x equal to 2, and they give you p of x here. They will give you this number. This number is p of 2. They give you this 0.22 something, and then they will give you 2 or fewer. All these add together from here to 0, right? Add together x or x equal to 2 or fewer. And then they will also give you sigma x, p of x equal to 2 or more. So they give you these 3 numbers, so you can use them to do a lot of probability. Okay, if you want to know what is probability of x equal to 3, so you can do that also. You will just change this to 3, and re-evaluate. Okay, evaluate. It will change to 3. Oh, when I have the probability of having 3 heads is this number. Well, what about 4 heads? And even the one that we know how to calculate by hand, all no heads, they're all tail. I can evaluate, and that is actually here. So you do get 0, they will give you actually a list of all of them. And it's convenient, then you can just, if you, in case you want to do in between, then you can just pick them. But if you want a particular number like 6, they will just give you a number. So again, if you do 0, they will give you a whole, and then evaluate, they will give you the whole table. If you use 1, 2, 3, they will just give you one number. Okay, but in all cases, they give you X or fewer. So let's use, let's do a few examples. Oh, and also the other one that the binomial calculator is useful is you can calculate the parameter by using a formula as well as by using StatDisk. So you can find the parameter by hand calculation. N times P is mu, NPQ is sigma square root of NPQ is standard deviation. And then the range rule of thumb that is not significant, that is usually what happen is mu minus 2 sigma and mu plus 2 sigma. But if you don't want to calculate this by hand, StatDisk actually show these also. So if you go here, you will see that in the bottom, mean is 3. Standard deviation is 1.2247. Variance is 1.5. So they do show up here. And if you're not talking about tossing coin, you can talk about 1/6. Can I do fraction? I don't know. 1/6 like in tossing a die. Toss a die 10 times. I want to know how likely I would to get 4. No, I think you cannot do 1/6. So 1/6 is what? In decimal, they require decimal. 1/6. 0.167. 0.16667. So give it a little bit more. Evaluate. So wow, to get 4 is actually 0.05. This is actually quite possible. Okay, so that's how you do it. So let's just do a few more examples so you can see how to do it. In a college, 35% of all students are full-time students. All of them, out of all the students, 35 are full-time. So I'm counting full-time, right? So the probability of X is number of full-time out of 11. Out of this 11, there could be 0 up to 11 all full-time. Can it be modeled by binomial? So let's check the 4 things. Is it a fixed number of trial? Yes, I'm counting 11. Independent? Yes, independent, because it is a big population. I'm only selecting 11. 2 outcome? Yes, full-time and not full-time. Full-time and not. And full-time is the success. Probability of what? Full-time? One full-time in one trials. I pick one student. It is full-time is 0.35, right? So I have N and I have P. This is P. So these two will determine your binomial distribution. So you say yes, it satisfies this 4 requirement, and you can actually figure out what N and P is. What is the probability that there are 4? So that is X, right? X equal to 4 out of 11. So you would say X equal to 4. So let's do StatDisk. We are selecting 11 students. 35% are full-time, and I want what? 4 full-time. So I evaluate. Probability of exactly 4 out of 11 is 242. Oh, 243. 0.243. Use P of X equal to 0.243. Because you want exactly 4. Right? So sometimes the question would be like this. What is the probability that there are less than 5 full-times? Less than 5 could be 4, could be 3, could be 2, could be 1, could be 0, right? So I want to add all of these together. X could be equal to this. So I want probability of X 4, 3, 2, 1, and 0. Of course, you can do a 0 and then add them. But you can just say, well, I start off at 4. So maybe I'll just use 4, evaluate, and these are all 4 or fewer, right? 4 or fewer, 0.668. That's it. They calculate it for you. Use peak of fear. So that is 0.668. What is the probability that there are more than 3? What is more than 3? So not exactly just 4, but 4, 5, all the way up to 11, right? So it's 4 or more, 4 or greater. So x is 4 or greater. Yeah. So I would say x equal to 4 and then do x or greater. So x or greater is 0.574. So you can see it is useful, but you just have to know which one you are to use. So there's some tricky one. Okay, example 2. A big store manager estimated that 9.5%. In decimal, what is it? 9.5%, I move 1, 2. So 0.095 of all customers coming in the store will buy a book. So probability of someone will buy, one person buy a book in one trial is 0.095. And then I have 24 customers I'm looking at. So N is 24. Can this be modeled by binomial? Yes. Right? Because it's 24, N is 24, it's always fixed. Do I have my two outcomes? Are they independent? Well, it's person coming in. They either buy or no buy. They don't interfere with each other. The two outcome buy, not buy. And do I know what is the probability that someone will buy? Is always P is 0.095. Someone will buy is 0.095. So this is possible. N equal to 25, P equal to 0.095. Find the probability that exactly 3 will buy out of 24. So I will change this to 24. I will change this to 0.095. And I say 3 because I want to know exactly 3 customers. And then I read out P of X, 0.213. Right? So enter this and answer X equal to 3, evaluate P of X equal to 0.213. So that's 21% chance that 3 customers will buy a book. Find the probability that at least 5. What does at least 5 means? So maybe 5 customers, 6 customers, all the way to 24 customers. So if you are doing adding the table, that's too much to add. So you will do x or greater starting at 5. 5 and then x and greater, right? So you add these together. So you would use 5, change it to 5 and evaluate again. And then use x or greater 5. That means 5 or greater, 0.071. 0.071. Use the last one, x or greater 1. You don't use any of these. Find the probability at most 2 will buy a book. At most 2 means what? The highest is 2, so that means 0, 1, 2. So I would use x equal to 2, and it is 2 or fewer because this is 2, 1, 0 is 2 or fewer. So I keep this the same. I do 2 here, evaluate. I don't need this and this. I only need 2 or fewer, 0.598. So equal to 0.598. Okay. So I'm going to stop here and then we'll do example on non-significant range in the next video and also more practical example.